Now let's talk about a little bit about really SanDisk implementation for them. Maybe a couple words about our relationship with this team and with VAIO filter. We work with VMware probably 4 years already, or something like that. And in some point, they cancel vFlash program, VFRC, it's 5.5, but you will not see this for 6.0. And they decided, for caching at least, to let third-party companies to deliver caching for them. After that, we met them on different levels in their management and engineering hierarchy. And we're very glad that they decided to work with us. After that, we worked like this. They said, okay guys, it must be write back and write through, but write back mandatory. We said, okay, we have write back, and by the way, we had already pretty much done write back on PSA level filtering. And basically what we did, we told them about our PSA level filter and how write back works in this case. And they were satisfied with a caching, write back caching idea that we had, but they told us, okay, instead of single kernel driver, now, sorry guys, you will go into each machine in the cluster. And we say, okay, let's define the interface. Now let's talk about write-back cache. Any questions, by the way? No? No?
Keep going.
Okay. Any questions, please, anytime. Let's think about write-back cache. First of all, it must be high available, right? It means that if node crash, VM will go to other nodes, and we should guarantee that this VM will be able to start, right? vMotion must work. If VM is here, we have some dirty data, not flushed data, on SSD, and machine move from here to here, we must satisfy timeout, vMotion timeout, and machine must be started here. For us, it is very important to support nodes that do not have SSD at all, because sometimes it's a big cluster, maybe it's a little bit expensive to install SSD everywhere. Machine may move here, no acceleration, but machine must be started here. Okay, so somehow we have to provide high availability, and number one, and number two, vMotion must be supported. It means...
I have a quick question.
Yes, sure.
In your previous release, HA was made with the pairs of servers.
Same here.
Same here, okay.
Yeah. Because you see, we have already this pairs implemented as a write-back support from both of them for high availability, and this two-node design that we have already after QA.
But then when you move a machine from one server to other server,
it's a little bit different. That's a little bit different. vMotion and high availability are slightly different. Let's talk about vMotion first, and after that you see how high availability works, because requirements are different. Just for clarification, in addition to our instance that is sitting inside each machine, we ask them about daemon. This is a special user mode process that will be started, and will have, again, our DLL will be inside, it will be inside this daemon. For high availability, each instance replicate data to the daemon to this machine, and all instances here, replicate data to this daemon. So daemon is a very important part of our design for high availability. Initialization will go through this, just machine booted up, and of course we read information from here, and we just initialize the whole system, and after that, when machine is up, it will be our part of our software as an instance will start, and everything from SSD will be already discovered. So this errors identifies data replication for high availability. Now about vMotion. If machine moves, we'll talk about high availability a little bit later. When machine moves from here, let's say, to here, first of all, vDisk will be closed here. Right after vMotion procedure, vDisk will be closed here. VMware, with this API, with filtering API, will give us lots of events. Close, as well as open, of course. But close is important for vMotion. In case of close, we can flush the data, and it will be data will be just a part of close procedure. So machine will not be started here unless data would not be flushed. However, it kind of requires having a relatively small amount of dirty data, right? Because flush, and after that vMotion will be started. That hurts performance. Because of that, they give us, and Alex told about this, so I can easily talk about this. They will give us some asynchronous events, for example, pre-vMotion notification. If we want to have more dirty data, they will ask them to give us 2 minutes, let's say 3 minutes, 5 minutes pre-notification about vMotion. So machine will be moved later in 1 minute, let's say, or 2 minutes. It gives us a time to flush data. And I told you that it's very good to work together with them. For example, we specifically asked them about pre-vMotion.
Yeah, but that must be assuming that DRS is moving the VM, not a person.
Right. What if I'm doing it right now?
Right now, yes, you're absolutely right. If right now, it will be moved. But again...
No, I mean, so you're saying I would get advance notice 2, 3, 5, whatever minutes that a vMotion is coming.
Okay, if it is absolutely urgent, okay, the VM, it will be special note, do it. This VM is for immediately move.
Okay, so the API will communicate that to you.
API will communicate this, and we will know. Actually, it is our attribute that defines how much dirty data we'll keep for this virtual machine. Mm-hmm. If it's small amount, if you want to do it like this, by the way, for maintenance, you don't need no rush, okay?
Yeah.
If you move it in 5 minutes, who cares? But if it's DRS, or you can wait for maintenance, for example, you will see, wait a little bit before starting VM, you will see significant benefits from working with these asynchronous notifications, because you will have more dirty data. And last time we talked about this, the more dirty data you have, actually the better write-back performance. So we want it.
So that's for any vMotion other than the manual vMotion, other than the one that you're saying, click now.
Yes.
That will be done immediately. All others,
yes,
like putting a whole host of maintenance, is going to put the dirty data for. Okay.
You will tell us.
Yep.
You will tell us. This will be totally controlled by us.
Well, no, I mean it's not a checkbox that you say, okay, give it some time to vMotion, right? That's nowhere. That's not available, right?
No.
So it will be either in the DRS, the putting in maintenance mode, and it will do it immediately on a manual vMotion.
Yes.
Yeah. Okay.
It's
great.
absolutely true. Or if you want to wait because you move machine not very often for maintenance, right? You say, okay, for this, because I'm going to use vMotion only for maintenance, I can wait. You'll have better performance, but you have to wait a little bit, minutes.
So, so how do we tell it, though? That's the question.
Yeah.
How does it know if I want it to go right now or if I want it to wait?
Change the parameter, will keep less or more dirty data. That's it.
And how are those parameters defined and stored? Like, where's that policy held?
Yeah, where do I click?
It will be our API to our system. Say this, for example, for all VMs, I want to switch to immediate.
So it's a policy in your management
It's our policy.
system. Yeah,
Yes,
okay.
yeah. Because you can, in our caching implementation, you can keep amount of dirty data, as much dirty data as you like, and we'll just, okay, it'll keep like this. Not let everything will be immediately. But before that, it will be really, really better performance, for better performance. Same for snapshots, by the way. We will have pre-snapshot notification, because for snapshot we must flush. Because remember, we are very high in altitude. And if it is NFS storage and snapshot, we must flush. Or it will be, again, small amount, which is configurable, as it but basically it depends on how good the storage to be able to flush. Or, again, we have pre-snapshot notification, we can flush, and after that, a snapshot will be created. Again, thanks for VMware, this is very useful. Now in case of crash. If machine crash, oh, by the way, machine shutdown is always clear, because upon close we flush everything is fine. In case crash, we have dirty data here, and if virtual machine will be start here as a part of failover, our persistent metadata will tell our instance here what server we have to ask. And by the way, we will know about crash, who was master, who was slave. Now master was down, machine is here, data is here, we're flushing. Here another very important example how important to work very close with VMware. Because you see, in some point I have to stop telling you, because that's not Alex told to everybody, okay? Sorry, I just wanted to tell you. Anyway, they give us API to start virtual machine without failure, keeping flushing from here and finish flushing from here.
So the HA restart won't occur until the flush is complete?
Yes.
Okay.
Again, good example of working with them.
Architecturally, we keep talking about setting policy. Where is that policy held and stored, and who defines the policies that can be stored? So you apply a policy to a particular virtual disk, you say, I want this amount of dirty data, these kinds of behaviors. Mm-hmm. Where's that actually stored? And
well, they call it site.
So it's
okay.
One way you can answer this is VMware stores this, or we store this.
They gave us all mechanism to store it.
Cool.
And that's
including a taxonomy of the kinds of data that can be stored, all of that.
Your interaction is via the API,
cool.
Where it's actually held in the interface that's managing that to be determined.
Yeah. You know, initially, I can tell you about our previous design easily. We have our special shadow file with our parameters. We partially use descriptor file, but descriptor file can be asynchronously overwritten. That created a lot of synchronization problems for us. So we have a special file next to VMDK where we keep our persistent metadata. But guess what the problem we had? Storage vMotion. Who will copy our file from, you see what I mean? descriptor will be moved, virtual disk will be moved, but sorry, not our file. Nobody knows about this. So it was just dancing around how to manage this. No problem at all so far. And again, we told them about persistent attributes. For example, accelerate, what VMDK, what accelerated, what mode for acceleration, what's the status for example, if this node SSD is down, we start flushing, and after that we switch to write-through mode. It's a lot of information that we need, persistent attributes for each object that we accelerate. We need, and we keep it already in a container that they gave us, which is very, again, for us it's very important. Storage vMotion was a headache. Now it is okay. So I told you already a little bit about motion snapshot works, and storage vMotion completely invisible for us. We don't, pretty much we don't care about storage vMotion, and we cared about this in the past just because of this problem of copying our persistent attributes. We will support write-through and write-back mode, both. Any virtual disk can be in write-through and write-back mode. We will support all these modes for different virtual disks. Capabilities that we had in the past, we talk about probably in a previous VMworld. If you maybe stop in a SanDisk booth, we talk about quality of service. Everything will be there, because everything what was and the part of our caching engine will just take this caching engine and it works as it is, just with different APIs for IO filtering. So that's basically the idea beyond our integration with VMware. If you want to add something, so please.
I just wanted, if there is any question about why we like having more dirty data for increased performance, is that a question, or is that something well understood?
Just more data in cache that you can use.
Exactly.
Go to the storage.
Exactly. Your write cancellation, write coalescing is increased, so you get better performance.
I'm
with
more
write-back
concerned with
caching.
if one of those user world spaces that you're running your software for the VM has an issue. I know your fault domain is no longer the whole kernel, but if there is an issue at the VM level, I mean, what happens to that data?
Okay. Let's separate this. First of all, it's a guest VM or VMX. VMX problem, of course, VMX crash as well as kernel, but VMX is VMX.
Right.
It is a part of ESX.
So you're saying it kind of all goes down at that point?
Yes.
Yeah, okay.
So you see, whatever VM will do, we don't care. Even if machine crashed, OS crashed, guest, OS crashed, this VM as a process is alive. It will continue flush and will flush. Another example, by the way, with this delete. If you think about this, it's very painful without VMware. Let's say it's write-back cache. We're flushing, and suddenly, because machines has been shut down, after that, from this node, from vCenter and from this node, they decided to destroy this machine and delete VMDK, and I'll continue flushing. Oops, this space already, but actually they will not be able even to delete, because when we flush, we open virtual disk. So if machine shut down, if machine is shut down, it's not vMotion, it's completely shut down. Upon close, we flush, of course. But if machine crash, we start flushing here, and somebody deleted from there. You see, many small problems that you have to take care having write-back mode. And again, we specifically talked to them about delete support, and it is handled. VMDK delete.
So you're keeping an open handle at all times. You keep an open handle on the VMDK until you're done doing whatever you do. You won't let me.
If machine is running,
Running makes
Same.
sense, but if you're describing your situation, you just keep
It's exceptional, only in case of crash.
Yeah.
Because upon close, we'll do it.
Okay.
We'll do it. But
VMX has the handle open rather than.
Well, no, he's saying if
this.
it's powered off.
no, if
and
machine crashes, I'm
crashes,
here.
gets powered off.
Start
It's like this
flushing.
whole Rube
Yeah.
Goldberg.
I must
machine.
start flushing.
Yeah.
Exactly. So that's a lot of problems. Machine crash my data here. I must open virtual disk. That prevents from opening virtual disk somewhere else. And it was a lot of conversation with them how to handle this. Again, excellent team. And we found together, actually they found a solution to satisfy this. Alex mentioned about shared memory. All instances and daemon, they have available piece of in a shared piece of the memory, and all interaction between them actually was done through this shared memory. It was a very important part of design. They develop very switching, because you see that's the switching from user mode to the kernel, from the kernel to the user mode. This round trip, they guarantee not more than 20 microseconds. And we specifically talk about this. It will be one switch only, and basically they guarantee small latency in this case. So if it's in a magnitude of 10 microseconds, it is okay, I would say. So that's basically on a surface where we are together with them.
Just a quick, kind of operational question.
Yes.
Is deploying the software then just dropping a VIB on the host?
Yes.
Not the, okay. Not the, I understand the APIs are different, but yeah. So no
problem
agents
at all.
running or anything, VMs,
No.
goofiness. It's all in the hypervisor. Okay. You had to ask because some folks use agents, some don't. So,
Oh, we're inside VM,
yeah.
but we're not inside. We're outside of guest.
Okay.
It's VMX.
So admin and engineer operational challenges are drop VIB, reboot.
It's a weep, bomb. It's we're citizen.
Yeah.
Hopefully a good citizen. Yeah, that's what we like.
We love these new APIs and mechanisms. You have much more information than in the past. So also for the
yes.
analytics, it will be there will be an advancement. So you will be able to measure many more parameters and give to the user something more than today.
You're going after more scalable management, really, right?
Now, how to say, in terms of information that we have some additional notification like vMotion, snapshot notification, but being here in the stack, we saw everything. So we saw here, and we can see it from here. I would say what's more important, for example, we'll have not less that we had being in a kernel and just trying to find something from just dirty corners. For example, for quality of service, we want to understand for what resource pool machine belongs to. It is available for us now, and previously it was just on the table. What else they can give us? For example, for kernel implementation for 5.5, we have our own LVM, because if you want to aggregate several PCIe SSDs, we have to use the original native LVM, that is concatenation, and it requires mounting VMFS on the top with some overhead. Now they grab from somebody else in VMware. VMware is a big company, LVM with RAID 0 and RAID 10 as far as I remember, and we don't have any problems with PCIe, so we don't need our LVM. We'll use their native LVM that they developed for some other projects. That's a lot of advantages because they care about us. Of course, we care about them.
I think it's important also to emphasize that when Sergey's speaking from the perspective of we as a vendor about these APIs are open, right? This will be any vendor delivering a caching solution for ESX6 will have access to this data. This is going to be, a public program. The beta is currently private and limited, but we've been co-developing with the idea that this is the future for all third parties to bring caching solutions into ESX.
Yes. I sound very selfish, looks like.
You keep on talking about what we used to have to do, right? And that's the point. What we're going forward to is actually a better and more level playing field for all players.
All your features in here are feature parity with the native API. Nothing in here is direct SDK. Nothing. It's all API available.
That's the point.
So thank you that's very important what Rich mentioned. From day one, they told us we don't want to do anything specifically for you. We want to do, if you prove that it's not only because of you, we will do it. It's only for you, we will not do it. So it was several iterations between them and us when we say, okay, we give up this, but you'll do this. Or say, okay, and vice versa. So it's really what I'm talking about. It is line from here, API that they provide for everybody. Here we are, and we are happy with this API. And basically they told us, if it's enough for you, it will be enough for everybody. Because really we ask a lot.
We're the squeaky wheel.
Yes. The question always comes when we have stuff that's where this is great, you're contributing back to the API, you're ultimately developing the ecosystem for yourself, for customers,
right.
And you're also developing it for other partners as well.
Absolutely.
What differentiates the SanDisk offering from somebody else who has native capability to leverage the same API?
That's a great question, because what that does is that throws it back onto the core caching technology that we started out with, which is cache capacity, cache efficiency, utilization of system resources like CPU and memory, methodologies for protecting data.
Kind of sounds like a question like everyone can do NFS fiber channel iSCSI.
Yeah.
So is all storage the same?
Exactly.
No,
exactly.
The better one is actually VAI. I mean, VAI is just, it's for everyone the same, but how they implement it is hugely different.
Yes.
Exactly.
So we have very unique caching technique, what we call log structure cache, metadata caching to minimize our footprint in the memory. So we have lots of, because what's good, we have caching engine that works for Windows, Linux, ESX, Hyper-V. And because of that, caching engine is exactly the same. It supports write through and write back, switching between them, supports high availability, and it's exactly the same caching engine here. But we're happy working with VMware, but secret sources, it's a caching, of course.
From a management perspective, would there be management to be done on a SanDisk UI? Would that be a plugin?
Plugin, absolutely.
Plugin, okay.
For them, it's exactly the same. Across all platforms, by the way, we want to be as native from GUI standpoint of view as possible. It will be native plugin, absolutely.
But again,
I would have been surprised if the answer was different.
Right. So for the average administrator, for the average administrator looking at the GUI is clearly the way to view into this. But management interfaces for large-scale deployment and manageability is another point for differentiation among different vendors.
Right.
Any questions? More?
How do we get it?
Wait a year.
So I assume that this will specifically work with version 6.
Yes.
Going forward, you're not going to try
It
to
is version 6.
hammer this back.
Starting from 6.
Do you plan to continue working with VMware on these APIs after the initial release?
So far, we're happy. But I can tell you that
Very careful answer.
I cannot imagine that I'll be happy the rest of my life. So
Very careful
I
answer.
cannot guarantee. But they're very responsive. Again, we have a partner from that side. They're very reasonable. Really, that's a great engineers from their side. And we have just, we didn't have any discussions, do we need it or not? They didn't ask, why do you need it? Because we, oh, okay. And after that we talk about just compromises from both sides. Engineers are great.
It's when the marketing people get in the way that everything goes south.
By the way, I just, somebody in a previous tech field day, Colorado, asked about replication for disaster recovery and write-back caching. You know, life is changing dramatically. It is very important that they offer this filtering API for replication for disaster recovery software. I anticipate that all providers, this disaster recovery providers, will switch to this. And VMware, as far as I can see, they push functionality from the hardware level to the software level. And because of that, as I mentioned, replication will be above us in the stack. So we'll be below, and we will satisfy replication on the top of on the top of us. Mm-hmm. So I see the trend. Now maybe, if I have maybe a few more minutes, I hope so. Maybe we can talk a little bit about write-back caching, write-through caching, write-back caching. Why?
Do you want a whiteboard instead of?
No, I just that's okay. We can talk about.
I'm just going to pin one quick thing.
Yes, sure.
So, is there a fear that with the next iteration of vSphere, that everybody's not necessarily going to jump in because we all got told to jump in with VFRC and now it's gone? Is there a concern that people are going to sit back because it's 6.0 and say, let's wait till
anyone that actually
0.1?
Played with VFRC immediately said this is crap.
The proof of the pudding is in the tasting. So it was an interesting experience for us when everybody said, well, now you're competing against VMware, aren't you? And
competing.
Exactly. No, truthfully, but truthfully, it is our intention to bring our implementation for the IO filter APIs out to market with the launch of ESX6. So you'll get your hands on it very early. You'll be able to see what you like, what you don't like. Hopefully APIs, public APIs won't change very frequently, so that we will have a consistent set that all vendors can program against. But definitely there'll be room for improvement beyond the first launch, yeah.
That's actually this question, maybe just continue answering this question, because what I wanted to tell you about write-back and these capabilities as well, it's a kind of answering your question. First of all, team is so good that I doubt that they will just not deliver, number one. It's a very good team. Number two, for the company like VMware, with, frankly speaking, poor ecosystem, it is important for their future to develop powerful ecosystem for partners. And they suffer without this, they're losing partners, or partners play against them, so now that's under their control. And one more thing that actually I'd like to tell about, it's my view, my vision, it's, don't take me wrong. But you see, write-back is very important for VMware for the future. What they did, by the way, for developing this API, instead of developing API first and after that developing software that used this API, they did something completely opposite. They asked us what API you need, because we have write-back caching. And after that we say, we need this. We say, okay, we'll implement this. With of course, with some, after reaching agreement between them and us. But they need write-back cache. If you want to put big data or private cloud being virtualized or VDI. The VDI has lots of writes. Initially reads, but after that writes. You need write back. Private cloud, Hadoop. Look at how many writes they have. Random, sequential, at random, a lot of random. So it means that for them, having efficient write-back cache, because at this moment, as far as I know, they're not going to develop their own cache. At least they didn't. They're helping us, which is a good sign. Write-back is very important for them. And because of that, just for their business, for acceleration. Because of that, I seriously, I pretty much convinced that from their side, we'll have all support and this program will succeed. VFRC was not successful because of vFlash API. They use vFlash API and they didn't succeed. And why all of us, we said no, vFlash is not good for us because we didn't want to fail. But now they did everything in this API in the right order. They say, okay, what do you need? We develop for real caching. That's why I'm pretty much, as I said, convinced that they will deliver. And by the way, whatever they promise to deliver, there is no delays from their side. It's a drop after drop.
They can keep VFRC, we'll call it VMware for real caching now. I like that.
It's a real caching. Yes. That's true. That's true. And I mentioned already, so write-back is important for their business. So I strongly believe that caching has a future and substantial future for virtual world. Mm-hmm. More questions?
Yeah, we're coming down to the wrap-up period. Any last questions? Any general questions about SanDisk and what we're doing? You know, we probably will be seeing you again at a storage field day soon, and we'll be able to let Sergey speak a little more freely.
Did you see a fundamental change in how VMware worked with you as a partner in the design process in this versus any previous work you've done because of how much they wanted their API to work?
You kidding me?
we know we
So
he's the straw man. He's just throwing in those softballs.
You know, we're just sitting months in front of the closed door and just, can we? No, they're very open. It's a great relationship now. Mm-hmm. We're just no complaints. Can you imagine this? We're so spoiled and no complaints. Yeah, that's very, very nice now to work with VMware. Mm-hmm. Cannot be better. I can tell you that maybe it's a news for you, but if you do not compete VMware, it's very nice.
Drop the mic.
Yeah, exactly. Everybody's now competing with VMware because they're competing with everybody.
No, that you see, that's
Normally they start competing with more people as they did yesterday, rather than doing less competition.
right. Okay, any technical questions? It's a million details. And we enjoy developing this. It's a very interesting project.